Good morning. This is chapter 4 for week 4. That the topic is business hardware. Hardware is what we are the what do you mean by hardware? First of all, hardware is something that you can touch, you can feel, and you can see physically. You can touch physically that are used to store information. So what are these business hardwares that we are using for information technology? Okay, these are the, first of all, let's list all the major hardware components of computers and explain their functions. And then after that, we will classify computers into major categories and identify their strengths and weaknesses. What are the major categories of computers? Identify and evaluate three criteria. Another word for criteria are the standards that we will use for deciding what computers excuse me, what computers to buy so that we can use in our organization. And then discuss the possible health hazards of computer use. Is there a health hazard if you use a computer or an iPhone or a smartphone or even this little phone here that is there a hazard for that? Okay, we will discuss it. Now, what is hardware? Hardware, as I said, is the physical components of computers and related electronic devices. These are run by power. It needs to have some power. The power can be a battery or it can be connected to electricity. Now, computers have two parts. We have the software and the hardware. The software is what we call the programs to do a certain work. Okay, but the hardware is where you put the programs, and the hardware is the one that runs the program. Now, the hardware has four operations, and that also goes with the software. Number one, it accepts data. Now, we already talked about data. Data are words and numbers and symbols that have no meaning. Once you put the data together, you put the words together, you put the numbers together, and you put the symbols together, now they will have some meaning that can be used for decision making. Remember, our ultimate reason why we have information is to be able to make a business decision. Okay? And then after accepting the data, the hardware will store the data and the instructions as to what to do with that data. And it will now process the data into information. Information is words, numbers, and data that has meaning. Meaning, okay, it means something to us that we can use for decision making. And then after the information is processed, now we have the information. We have information. And now it's time for us to decide. So there are four basic operations of a computer, whether it's software or hardware. Accept the data, store the data and instructions, process the data, and output, or now we have information. So these are the general hardware components of the computer. In general, every computer has the following components: input devices, okay, central processing unit, internal memory, storage, and output devices. Now, what are input devices? This is the keyboard. An example of a hardware input device is a keyboard. This keyboard here, see? This keyboard. This is an input device, okay? And maybe the camera that we are using right now is an input device. Now, with the central processing unit is where the data is changed into information. So they put the words together, they add numbers together. The computer knows how to do that. And then you have the internal memory, wherein they work on this data. Okay, it has to be stored somewhere. It's a memory. And then you have the external storage. You can put it on a flash drive, or you can put it there. And then you have an output device, which is like the printer. I have a printer here. Okay, so it prints all this work. So here is the example: output devices, input devices, the mouse, the microphone. Okay, and then you have the storage, the CD, the hard disk, the cloud storage. Right now we have the cloud storage. You save, you rent a storage on the cloud. And then you have the internal memory, the random access memory, and the ROM to turn on the computer. And then you have the central processing unit. The central processing unit has ALU, arithmetic, logic. You know how the how, if you will be asking, how come the computer knows how to add 1 plus 1? Because of this ALU here. Okay, because of the ALU. Okay. Now, so the computer hardware central processing unit accepts instructions and data, decodes and executes the instructions, stores the results in the memory, and then now you have the internal memory, you have the random access memory, and then you have only the read-only memory. On the random access memory, this is the memory where the data is there as long as the computer is turned on. Once you turn off the computer, everything on the RAM disappears. Okay? Now you have to put it again. Once you turn on the computer, now you type something on the keyboard, it goes to the RAM. The read-only memory is where the instructions or the program for add, subtract, divide, and multiply, okay, or a logic, greater than, less than, or equals to, okay. And then you have the motherboard, the circuit board containing the CPU and the primary memory. You have the storage. Examples are magnetic disks, magnetic tapes, DVDs, for those of us who like to listen to music. And then you have the flash memory, okay. And then now you have the output devices, delivers information from the computer to the user. Now we have the monitor. You can see, like right now, you guys are watching the monitor. That's an output device. Audio, you listen to my voice, okay, or I'm listening to you too. So that's an output device. Okay. Now, how does the computer store information? It stores information by using binary numbers. Binary numbers are two numbers only, which is zeros and ones. And then if you have 8 bits of zeros and one, it becomes a byte. A byte is a word, a number, you know, that we call data. That is how computers store information. And this is all put in the memory of the computer. Now, the computer has storage capacities like megabytes. What's megabytes? Okay, 1,000 bytes, gigabytes, billion bytes, or trillion bytes. So you have megabytes. How big is your computer? It's 10 megabytes. So that's very small. And then how big is your computer? Oh, it's a gigabyte. Okay, 10 gigabytes. Oh my God. Now you have a very big computer. Or those big computers like owned by Amazon, they have terabytes. They have terabytes as their computer memory where they store all this information. Okay, so this is kilobyte, megabyte, gigabyte, terabyte, petabyte. These are now becoming EB byte, exact byte, zettabyte, and yottabytes. So these are the memories of the computer. Now, what is 1 byte? 1 byte is one word. So 1 kilobyte, you can have 1,000 words there or 1,000 numbers. This one, you can have 1 million numbers, megabyte. This one, you can have 1 trillion words in the memory of that computer. You know, it's very hard to, it will take time for you to fill up a 1 gigabyte memory. Okay, how big is your brain? My brain is very small, less than 1 kilobyte. Okay. Okay. Now, classification of computers. Computers vary in size and power. Now, so the size is 1 megabyte. All these things that we talked about a while ago. Those are the sizes of the computer. And then now, how do you classify the computer as far as power is concerned? Power is determined mainly by the processing speed and memory size, the speed of the computer. More powerful computers are more expensive. Okay. Now we have supercomputers. Most powerful computers at any given time. The largest physical size is the most expensive, designed for complex arithmetic calculations, generally impractical for business purposes, the supercomputers. Now, like Amazon has it, FedEx has one of the supercomputers because they have to deliver all over the world these things that they have to deliver or whatever they have to do. The United States government has supercomputers. Okay, so it can also parallel processing. They have multiple processors running simultaneously, also known as multi-processing. Clustering uses the CPU for multi-processing. Okay, and then now you have the mainframe computers store large amounts of data and business transaction. Okay, this is now the second to the supercomputers. Less expensive and less powerful than supercomputers, often used by banks, universities, insurance companies, and central computer. Like insurance companies, they all these cars right now you have to buy insurance. Now they also compute like how many people will get into an accident in a day, so they have to do all those little arithmetics that they do. Okay, universities, we have to keep all records of all the students, you know, like your grades, okay, like after this class I have to put the attendance. If you that's why you have to kind of text email me that you got this uh, lecture and tell me something about what we talk about here. And then I will give you an attendance and a grade for immigration purposes. Okay. Significant amount of world business data resides on mainframes. And then it also uses multiple processor to process data into information. Now, servers, mid-range category of computers after so we have supercomputers, we have the mainframes, now we have the servers. Smaller and less powerful than the mainframes, serves hundreds of users that connect from desktop, laptops, and other servers. Use multiple processors. Okay, so that's the way it works. So yeah, and then now you have the personal computers, PCs, collective names for several types of computers, notebook computers, desktop netbooks, and handheld computers. So these are like I'm using a PC right now. Okay, and then at my work, I have a workstation that's connected to the server of the company. And most powerful PCs use for CAD, complex simulations, graphic renderings, and scientific applications. So powers of PCs doubles every 2 years. You know, once upon a time, the computers were very slow and very small. Right now, they double in size every 2 years and power. Okay, so computers. So right now, let's say I bought a computer. Like somebody's on, how old is your computer? Oh, it was like 2 years ago. Oh, that's an old one. Okay, it doesn't anymore. Some of the programs don't work in the computer that you have. Okay, because those other programs were written for bigger computers, bigger memory of the computers. Okay, and then we have the notebook, the laptop. I always bring a laptop with me or a notebook. Uh, Personal digital assistant, handheld computers, stylus pen, smartphones. Yeah, the smartphones. This one, okay, smartphones. Okay, and I also have this phone here connected to my smartphone. Uh, they go hand in hand. So I don't have to bring the phone I don't have to bring my phone everywhere. It's kind of heavy, you know. Now this one is like in my hands here, so I can see the email. If one of you tells me that you just read this, I can see it from here, and then I mark you present on the attendance. Attendance is very important for you guys, okay? So don't forget that. Now we have the tablet mobile computing device that uses touch screen to execute commands. So the tablet, iPad, Microsoft Surface, Kindle Fire, if you want to read books on tablets. Some of you are doing that, I know. Okay. Now, the convergence technology, building several technologies into a single space of hardware, prominent in handheld devices. Smartphone is a prime example of a convergence technology. You can use it as a phone. You can use it cloud storage and data and networking. You can connect to other. It's real-time information, and it can also be a media. Media means you get information from the phone. Okay. Now, a peek inside the computer. Professionals must know how about the computer components to understand their power and capabilities. They use this knowledge to make good decisions in purchasing and recommending a computer. Now, what kind of computer are you going to buy? Okay, what kind of computer are you going to buy? Or what kind of computer are we going to use for a class in computer science? Okay, so the students have to know. They have to see the inside part of the computer. Okay, so we have the central processing unit, which is part of the motherboard. Okay, it has the ALU, control unit, and arithmetic and logic unit. Okay, it controls. The CPU is a silicon chip with multiple circuits, also known as a microprocessor. Multi-core processor that combine two or more CPUs or cores in a single chip. And then, so that's multi-core. And then multi-threading, processing more than one program or several parts of a program at the same time. Sometimes you can use Word, PowerPoint, like this one. You can see my video. Okay, this is a multi-threading that I'm doing here right now because you can see me and you can also see the PowerPoint. Okay, multi-threading. Okay, and then another, let's continue with the central processing unit. So microprocessors are embedded with transistor. Those little transistor radio. I don't know if you, once upon a time on the 60s, we buy a little radio. It was called a transistor radio, and you can listen music to it. But right now you have there was only like one transistor in a transistor radio. But right now we have so many transistors. It's a very small transistor radio that processes data into information. The machine cycles four operations performed by the CPU: fetch, decode, execute, and store. Fetch means get the data, decode it into words or numbers. Execute it means put it together or combine these words together so that it will have some meaning, and then store it. Okay. The CPU clock, special circuitry on the processor that synchronizes all the tasks. Okay. Synchronizes all this work together so that the like you will understand what I'm saying here. The clock rate, the number of pulses per second a machine cycle takes several clock pulses. Okay. So this is the way it works, central processing unit. So input device, the keyboard, it goes into the central processing unit. It adds 7 plus 5, and then it decodes, executes 7 plus 5 equals 12, and then now it shows on your output device whether it's a printer or the screen. Hey, now you know. And then you can also store it in the memory for future use. What is 7 plus 5? 12. You put it on the memory there. See how it works? Okay. Look at how it works. Input, processing, output. Okay. These are the machines that you use for each one of that. These are physical parts of the computer. They are physical parts. Okay. So this is the timing of computer processing operations. You know, the computer, they solve problems very fast. Millisecond, microsecond, nanosecond, picosecond, you know, like so fast. Okay, better than our brains. Okay, but sometimes our brains work better because we have kind of insight. Okay, we have kind of insight. Okay, so data word maximum number of bits that a control unit can fetch. Fetch means get. This means get from the primary memory in a single machine cycle. The current microcomputers have 32 to 64 bit words. The ALU is the arithmetic logic unit. It can do all these operations that perform arithmetic. What is arithmetic? Add, subtract, divide, multiply. Okay, those are the arithmetic operations. And logical operations are greater than, less than, or equals to. So we have 7 operations on the ALU. Add, arithmetic; subtract, arithmetic; multiply, arithmetic; divide, arithmetic. Logical operations, greater than, comparison. Is this greater than this? Is this larger than this? Is this smaller than this? Or are they equal? So 7 operations there. Okay. Now, computer power depends on the processing speed and memory. And then you have the bus. This is where all of these are running inside the motherboard. Okay, electronic lines and traces used for communication inside the computer. Now the throughput number of bits per second that the bus can accommodate. How many words can the bus accommodate? Like a bus, you ride a bus. Okay, how many people can ride the bus going from LA to Anaheim? Okay, now inside that motherboard, inside the computer, you also have bus to take the words, the numbers from one point to another. Okay, and the throughput is the speed inside those buses. Okay, so millions of instructions per second that is processed by the computer. That is the speed. It's called millions of instructions per second. So all of this knowledge that we're talking about here right now will make you decide what is the best computer for your organization. So these are the input devices again that we have. Computers must receive input to produce output. It's a system. System always has input, processing, and output. Those are the three parts of any system. Okay, that's why it's called a system. Input devices include machines and devices used to enter instructions and data into the computer. Now, what are examples of these? Keyboard is the number one example. The mouse, right now my hands is on the mouse, so I could click this PowerPoint. Trackball, you have the trackball. Microphone, now you're listening to me, you can listen to the microphone, and a scanner. I have the scanner here on the side, and I can scan documents to be sent to you, or to be sent to the school, or to be sent to anybody that needs some paper from me. Okay, so input device. Now we have the input device is QWERTY. QWERTY is if you're going to look at the top of the keyboard, it's QWRTY. Input device contains keys that users press to enter data. They have numbers, punctuations. QWERTY is the standard keyboard output. There's another guy who came up with this. His name is Dvorak. Keyboard layout that allows faster typing. Now, the keyboards are ergonomics. Okay, ergonomics. What is ergonomics? The study of the comfort and safety of humans in the workplace. Okay, that is the ergonomics. Um, the offices have to be comfort and safety of humans in the workplace. Ergonomics keyboard fits natural and forearms to prevent injury. Okay, and then other input. Excuse me. Other input devices are the mouse, the trackball, and the trackpad. Okay. Um, Now I'm sure all of you know how to use the mouse. Touch screen, some computers I don't have a touch screen. Okay. This is kind of I bought this computer like 2 years ago, and but if you're going to buy computers right now, they're all touch screen. Okay, they're all touch screen. Okay. Sources of data for input device. Okay. There are so many sources: optical marks, optical character recognition, radio frequency identification, fastest and growing source of data technology. Okay. So, and then you have when you buy something from the store, they have the universal product code, barcode on the product in a grocery store. And then you have the magnetic in character recognition, magnetic strips, credit cards. Okay, if you buy something like right now, some companies asking for my credit card, but I don't have my wallet with me, so barcodes on packages received through shipping companies. So these are the sources of data for the input devices, or those input devices that we just talked about. Okay, like this is a check here. Okay, imaging. imaging, okay, like what you use at the stores to save paper. Okay. Speech recognition, like right now, see, hey Siri, like hey Siri, call up this number, something like that. So I see my Siri phone is asking now, what number are you asking? So it's doing it right now, because I said hey Siri. Okay, but cancel. Hey Siri, cancel. Okay, now it's canceling it. Okay. Because I don't need, I'm not calling up anybody. I'm just using it as an example here. Output devices, monitors, printer, and speakers. Okay. So in the future, digital smell output is possible. Okay. So these are output devices. Number one is the monitor. Now you can see me through the monitor. Now, how are the monitors? You have small dots make up the images on the monitor. They're called pixels. The cathode ray tube inside, these are all that. Now my monitor here is a flat monitor, so we have a better monitor. And then we have the liquid crystal display, which is really very bright, like the new TV sets of LG right now. They are liquid. On it. Oh, my Siri is just talking to me. Yeah. I didn't get that. Could you try again? No, cancel. Okay, I'm talking to my phone here, but I have to turn the phone off. Okay, now it's off. So monitors, the resolution measures the picture sharpness, okay, number of pixels, the size, the brightness, contrast, the contrast, whether it's bright or, and then you have pixel per pitch. Now you have the printers, non-impact does not mechanically impact the paper, and then you have impact printers. Now my printer is a non-impact printer here, but it's a cheap one that I have. Okay, and then the storage. Now the storage is where you for future use. Okay, you have the cost, capacity, the you need to access the information right away, and the access mode. Okay, mode of access, sequential, direct access, and the flash drive. Sequential, it goes from top to bottom. Direct access, it goes directly to where your information is and gets it for you. Okay, and then now you have the USB drives, the flash drives. Okay, so this is sequential. It goes from part to part, direct access. So it reads like this, you know. And then magnetic tapes. It goes similar to the tape recorders, VCR. Now some of them are old technology right now. Okay, actually we're not even using this right now because you have YouTube, you have Netflix. Okay, that it's on the cloud. It's on the cloud. You rent it from the cloud. Magnetic disk, the hard disk. Mine. This computer that I have here is kind of small. That's why it takes time for me to uh, to export it and translate it into something else. Okay, optical disk. Okay, uh, recorded by treating the disk surface to reflect the light in different ways. Compact disc and digital video disc. The DVDs. Nobody's using this anymore right now because we have it all on the cloud, like Netflix and YouTube. And then the flash memory, the solid state, the I used to have a lot of these. I have to look for some of them because I don't even know where they are right now, and I have some very good information on them. Okay, and then you have direct attached storage, network attached storage connected to the cloud computing. What is an example of a cloud computing? Like Amazon is a cloud computing. You buy things from Amazon, they're on the cloud. You connect to them, and then they will show you oh, where what do you want to buy or something like that. Okay. So some of these are kind of not used anymore. Storage area network, redundancy array independent disk. Okay. Cloud storage. This is now the new thing. Everything is on the cloud. Amazon, YouTube. Okay, that's like this one that we're doing right now. After I do this, I'll put it on the cloud. So you guys, I'll give you a link, and then you guys can see, can get it from the link and listen to this discussion or lecture that we're having right now. Okay. For business consideration in evaluating storage media. Now, hey, what will I buy? Okay, what will I buy? So purpose of the storage, amount of data to be stored, okay, required speed of data storage, unit space portability, and the cost. Okay, so hey, these are the considerations that you have to, hey, um, how big should my storage be? Okay, so these are the kinds of storage here and how much information can you put on it. Okay, now you can look at this. Okay, so magnetic disk, very bulky. Hey, magnetic tape, not suitable for immediate processing, optical tape, CDs, DVDs, and the flash drive. Okay, now what are the considerations in purchasing the hardware? The space where you're going to put it, number one. Equipment, power, speed, memory, size, and capacity. Okay, and also the ergonomics. Remember the word ergonomics. How comfortable will you be with that computer? Okay, so compatibility. Okay, with the software, hardware, okay, and then the cost, the power consumption, and the noise. Some computers are very noisy. Okay, so here are more data about it. Okay, the factor, what to look for, and the score. You have some kind of a paper work that where you do this. Okay, scalability and updating the hardware. Sometimes you have to update the hardware because you had a small hard. Like this computer that I have right now, it's kind of very slow. Okay, because it's a 3-year computer. Okay. So summary, what did we talk about it? It's about the hardware. What is hardware? Something that you can touch, feel, and see. And then you have the other parts of the computer that are inside the motherboard, the CPU, the clock rate, the speed of the computer, how many bits on how many bits and bytes. What's a byte? A byte is a word or a number. And a byte is made up of bits. What are bits? Zeros and ones that you can store inside the computer hardware. Okay. And then you have the RAM volatile memory. What's the meaning? What's volatile memory? Once you turn up the computer, everything on the RAM is gone. And non-volatile, it does not require power. When you turn on the computer, it runs on the ROM. Okay, because it has to have some instructions as to what to do. If you turn it on. Okay, and then data is organized sequentially on tapes. Okay, and sometimes you have to take care of yourself so that you will not if you type on the keyboard for an hour, you have to rest for like 10 minutes and then go back to it so that you will not have the carpal tunnel. The carpal tunnel is a problem with your carpal here, so be careful with that.